Hello everyone, in this video we'll learn a program to create a linked list of n nodes and delete the last node of the list. There are three steps to delete last node of a linked list. First of all, we have to traverse the last node of the linked list, keeping track of the second last node in some temporary variable, that is second last node. If the last node is the head node, that means we have only one node in the linked list. Then make the head node as a null. Else disconnect the second last node with the last node. That is second last node arrow operator next is equal to null. Then finally free the memory occupied by the last node. Now 30 become the last node in the linked list. The next pointer field of last node is represented by null. That indicates to the end of the linked list. Let's see the code how to create a linked list with n nodes and delete the last node from the linked list. Then how to create a linked list? The first step of creating linked list of n nodes starts from defining node structure. Every node having two parts. The first part is known as data part and the second part is known as address part. We need a custom type to store our data and location of next link node. This is our node structure. Struct node. Struct is a keyword. Node is the name of the structure. Structure having two members. Data and next. Where data is the data you want to store in the list. And star next is a pointer to the same structure type. Node is the structure, name, and struct is a keyword. The star next will store location of next node if exist, otherwise null. The node structure may vary based on our requirement. You can also have user defined types as node data section. Then declare a pointer to node type variable to store link of first node of the linked list. You can also declare variable of node type along with node structure definition. There are two ways to define the structure variable: inside structure definition and outside structure definition. Now in this case, structure variable defined inside the structure definition. After that, declare two functions. First function is for create a linked list and second function is for traverse a linked list. Void is a return type, create list is the name of the function and function having one argument, that is n. N denotes total number of nodes in a linked list. In second function, void is a return type and traverse list is the name of the function. Then inside the main function, declare a variable n. N is for total number of nodes in a linked list. Then input number of nodes to create from user. Store it in a variable that is n. After that, call a create list function. When this function call, control transfer to the definition of create list function. With the help of create list function, we can create a list of n nodes. Void is the return type, create list is the name of the function, and int n is the parameter. Inside the function definition, declare two more helper variables of node type, that is struct node star new node comma star temp. Star new node and star temp are two helper variables of node type. If the value of n is greater than 0, then create our first node, that is head node. Use dynamic memory allocation to allocate memory for a node, that is head is equal to struct node star malloc function, then size of struct node. With the help of malloc function, we can dynamically allocate memory. If there is no memory to allocate for a head node, if head is equal to null, then print some error message and terminate the program. Otherwise, move to the next step. Then input data from user and assign to head using head arrow operator. Data is equal to data. At first, head node points to null, that is head arrow operator. Next is equal to null. Now we are done with head node. Then we should move to creation of other nodes. Copy reference of head to some other temporary variable, that is temp. Temp is equal to head. Now we will use temp to store reference of previous node. Then create n-1 nodes and add to the list. Apply a for loop for I is equal to 2, I is less than equal to n. And I++. Inside the definition of for loop, allocate memory and assign memory reference to a new node with the help of malloc function. If memory got allocated successfully, then read data from the user and assign to data section of new node. That is new node arrow operator. Data is equal to data, and make sure that new node points to null. Now link previous node with newly created node, that is temp arrow operator. Next is equal to new node. Then make current node as previous node using temp is equal to temp arrow operator. Next. Then I++. Again, repeat all the steps, and after that, call the traverse list function. When this function call, control transfer to the definition of traverse list function. Inside the definition of traverse list function, create a temporary variable for traversing and return if list is empty. If head is equal to null, then cout list is empty. Otherwise, assign reference of head node to a temp variable. Temp is equal to head. Then repeat below steps till temp not equal to null. And inside the definition of while loop, temp arrow operator data contain the current node data. You can print it or can perform some calculation on it. Once done, move to the next node using temp is equal to temp arrow operator next. Then again go to step 97. Again check the while condition. Temp is not equal to null. Then temp arrow operator data contain the current node data. Once done, move to the next node using temp is equal to temp arrow operator next. After that, declare a delete last node function. Void is the return type. Delete last node is the name of the function. And inside the main function, declare one integer variable choice. With the help of cout, display the message, press 1 to delete last node, and with cin input the value of choice. If user input choice 1, if the value of choice is equal to 1, then call the delete last node function. When this function call, control transfer to the definition of delete last node function. Inside the definition of delete last node function, create two variables of node type, toDelete and second last node. If head is equal to null, then with cout display the message list is already empty. There is no node in the linked list. Deletion is not possible. Otherwise, assign the value of head to toDelete and again assign the value of head to second last node. Then traverse to the last node of the list with the help of while loop, while toDelete arrow operator next not equal to null, then copy toDelete in second last node and toDelete arrow operator next in toDelete. When this condition becomes false, then check the if condition. If toDelete is equal to head, that means if the last node is the head node, then make the head node as null. Otherwise, disconnect the second last node with the last node, that is second last node arrow operator next is equal to null. And finally, free the memory occupied by the last node with the help of free operator, free toDelete. And finally with cout display the message successfully deleted last node of the list. After that, again call the traverse list function. This function display the linked list after deleting the last node of the linked list. Now run this code. After the execution of this code, enter the total number of nodes. Total number of nodes are 3. Enter the data of node 1. Enter the data of node 2. Then enter the data of node 3. Data in the linked list is 12, 13 and 14. Then press 1 to delete the last node. Now successfully deleted last node of the list. Then data in the linked list is 12 and 13. Only 2 nodes are there in the linked list after deleting the last node of the linked list.